we discuss examples also? तुम तो नहीं थे last class में, तुम भी नहीं थी. तो हाँ. So we discussed the Newton's first law, which is law of inertia. So anybody remembers what is Newton's first law?
Law of motion and inertia.
So can somebody explain what is that law?
Thank you. So it is if I'm driving the bus and he's standing on the bus and the window is open, he jumps, he fall out of the window.
No.
Then
And he jumps. And
When you apply the brakes.
when you apply the brakes, see, you was not. Who said that? You said.
So while I'm driving, he jumps and fall out of the window.
No.
No, I won't.
Okay. If you are sitting on the bus and the bus is moving, and you toss the ball up, will the ball hit you?
Yes.
No. You toss the ball. Okay. You thought the ball will stop there. That's why only then it can hit you, right? But you won't see that happening. It will again fall back in your hand. No.
When the blade
So when you're
breaks.
holding the ball is also moving with you, no? When the observer sees standing outside, when the observer sees you holding the ball is not at rest.
The ball is
Ball is moving along with
the
you.
bus.
Yeah, along everybody. With the bus, everybody inside the bus is also moving, na? So ball has a component of velocity in the horizontal direction. So when you toss, what outsider will see? That the ball is going like this. You see it's going up and down.
So if he jumps exactly at the time when I press the brakes,
He will land back on his same seat, same place from where he jumped. You can try that in the local train or anywhere.
let's rent the bus.
Congratulations, you will die.
See, we need stop.
So did we discuss examples of inertia? Applying the brakes and all, we've already discussed that, right?
एक हमने किया था
So-
बस वाला ये.
बस एक ही किए. Okay, let's discuss more examples. So what is inertia? That also we need to know. Vijay, I didn't believe it.
Totally not sleeping. Totally not smaller than the steering wheel.
This is zooming. What is this?
It's big too.
So what was inertia? What did I explain? What was inertia? Those who are present should be able to answer. First law is also called as law of inertia. But what is inertia?
It is the property with
Huh?
Resistance to change.
What?
motion
To change the state, whether it's moving or not. If the body is at rest, it will remain at
Remain at
rest.
State of
So
motion.
it tries to remain at rest. And if you try to change the state of motion of a body at rest, it resists that. Okay? So that property is called inertia. And if the body is moving, it tries to keep moving. The example is a bicycle. Like if a bicycle is at rest, it remains at rest. But when you pedal it, it comes into motion. When you stop pedaling, it still remains in motion.
After some time, like so.
So when external force, friction is acting, if there is no external force, it continues in motion. Okay? So that property of a body to continue to remain in its last state of motion is called inertia. Okay? So it is what? It is inherent property. We have done this. Inherent property of a body to resist any change in its state of motion. Okay? Okay, this is called inertia. So this is a property of every body. Okay? Like if you're running, you can't stop suddenly. Let's say you're running, can you stop suddenly? If you try to stop suddenly, you'll fall. Okay? So what is making you continue your motion? Inertia. See? Now, so some examples of inertia. So some examples of inertia is when a brake is applied in the running bus suddenly, all the passengers will fall forward.
So then no bus in maintain. No bus in maintain.
That's irrelevant right now for the discussion of inertia. Okay? So when the brakes are applied in the moving bus, passenger will fall forward. Just like that, when a stationary bus is suddenly accelerated, then passenger will fall back because everybody was at rest. So what is in play in both the cases? In the first case and in the second case? In the first case, it was inertia of motion, which compelled the passengers to fall forward. In the second case, it was inertia of rest. Okay, so inertia will change role, whether it was inertia of motion or it was inertia of rest. Inertia means resist, oppose, resist, or oppose. Any change in its state of motion. This is inertia. Okay? So one example of bus we done. Second example. When a branch of a tree is vigorously shaken, what happens?
You break and fall.
The fruits will break. Like if there is mango, right? When you vigorously shake the branch, what happens to the mango? Drops down. Why?
Because it breaks. Because then it will
Inertia of
Motion.
inertia of rest. The mango was at rest, and what was holding it? A very weak stem. When you suddenly give a jerk, okay, the mango remains at its own place wherever it was, and the stem moves forward or disconnects. Branch goes ahead, right? That's how. Likewise, if you have a wet towel, right, and you give it a jerk, what happens?
All the drops. The drop.
The drops fall
Molecules
down.
of water.
Okay, water droplets fall down. This is also inertia of rest of drops. Okay, inertia of rest of water drops. Okay, with this we will now start the Newton's second law of motion.
So what is example for rest of? Sorry, inertia. Example.
Running bus when the brakes are applied. When the brakes are applied. Now let us discuss Newton's second law of motion. So what was the first law? First law said, Newton's first law stated that a body continues to be in a state of rest or in uniform motion until any external force is applied on it. Okay? So the word force was introduced in the first law. That there is something called as force which is needed to change the state of motion. What Newton's second law gives is, क्या हो गया आज इतना late?
बाहर गए.
बाहर गया था. Newton's second law of motion, what it states is, okay, एक तो लेट आ रहा है, ऊपर से बातचीत, not allowed. ठीक है? So Newton's second law में, what force, how much force is acting on the body, okay, is given by Newton's second law. It is the quantitative measurement of the force, which is given by second law. So how do you measure force? So to measure force, Newton's second law states that force acting on the body is directly proportional to rate of change of this is the statement of second law. Force acting on the body is directly proportional to the rate of change of momentum of the body. Right? So there is a new word called momentum. Where what is momentum? Momentum of a body is given as the product of its mass and velocity. Okay, that is E is equal to mv. So it is a vector quantity. Momentum is also a vector quantity. So why momentum? Obviously, the force. What is force? Impact. Force is basically impact. Obviously, it will depend on both the mass and velocity of the object. Correct? Let us say this is a light object, okay? When I throw this object at you, okay, slowly, will it hurt you that much? No. But imagine a bullet, right? If it is a bullet, right? So I throw the bullet at you gently, it won't hurt you. But if I load it in a gun, and then
He will die under pressure of
pressure is a different thing. We will come to it later. So bullet, the same mass, now traveling at a very high speed, can kill you. The impact it will produce or generate will be so high because of velocity. Understood? Now, so in this case, mass of the bullet was constant. We varied its speed, and it produced different impacts. With less speed, less impact. High speed, very high impact. Okay. Now let's change the mass. Let's keep the velocity constant. Imagine you were sitting on the ground floor, and somebody drops a ping pong ball on your head from the terrace. Anything happened to you? Ping pong ball. Huh? Plastic. Tennis, table tennis ball, ping pong or table tennis. Nothing will happen. Now if a cricket ball is dropped from the same height, or a coconut is dropped, so he's smiling like he has an experience of coconut ball.
No, cricket ball.
Cricket ball. So if season ball is dropped from the same height, is there any change in velocity? Because gravity will accelerate both ping pong and cricket ball with the same acceleration. So both will hit with the same velocity. But now the impact will be different in case of cricket ball. Okay? So the impact, that is force, is a function of both mass and velocity. That's why the word momentum is devised. It depends on both mass as well as velocity of the object. Okay? But what Newton says, not only the impact depends on momentum, but also on how the momentum is changing. It depends on the rate of change of momentum. Now look at this. When a ball is coming at you, right? How do you grab the ball? Right there? Or you're taught to pull your hands back? So why are you taught to pull your hands back? What's different?
Reduce the impact.
Exactly. So what is happening? In the first case, the momentum is changing suddenly. Like it had some velocity and now it has no velocity. In how much time the momentum changed? In no time. Means a fraction of a second, very small time. But when you pull your hands back, what are you doing? What are you doing? The momentum is changing gradually, not suddenly. So you increase the time interval of the momentum to change to 0, because initial momentum it would have some value. Let us say it was a 1 kg mass and it was traveling with 10 meter per second. So 1 into 10 is, what is the momentum? 10 kg meter per second. And when you grab it, it becomes 0 at once, right? But now if you pull it back, say it becomes 0 after 0.3 second. So now you have an increased time duration. So what is the rate of change of momentum? So rate of change of momentum in the second case will be less. Okay? So let's write it mathematically. How do you write rate of change of momentum? So it is final momentum minus initial momentum divided by t. Okay, this is what is the rate. This is change in momentum. So what is this? mv minus mu divided by t. So this is what you see is rate of change of momentum. Final momentum minus initial momentum. So this becomes what? m v minus u by t.
G minus B by
And what is v minus u by t? What is this?
acceleration.
Acceleration. Very good. So we get this. So how much force is acting on the body is, you remove the proportionality, so you write kma, where k is the constant of proportionality. Where k is the constant of proportionality. Okay. So now if we choose the unit of force as 1 kg per meter, 1 kg meter per second square, then k will become, so what is k? Therefore k is equal to f upon ma. Okay? When will k become 1? If 1 unit of force is equal to 1 kg meter per second square, then k is equal to, what is unit of force? 1 kg meter per second square. Then replace the unit of mass kg and acceleration is meter per second square. So what will k become? So k becomes 1. Okay? So if we choose this unit of force, then value of k becomes 1. Right? Therefore, f is equal to ma. If unit of force in SI is chosen as this itself is named as Newton. Yes. kg मीटर पर सेकंड स्क्वायर को ही क्या बोलते हैं? न्यूटन. समझ आ गया? So this is what is. So this is the mathematical form of Newton's second law of motion, which gives you how to calculate force acting on a body. It is nothing but the mass of the body and the acceleration caused in the body due to the force acting on it. Just multiply it. Like if this duster is stationary, okay, if I apply some force on it, it will develop some acceleration. So when I multiply its mass with the acceleration developed, that is equal to the amount of force acting on the body. Okay. So everybody now read what is second law of motion and see if it makes sense to you. So here you can write one more step here, or you can write it as delta P. Change in momentum is delta P by delta T. So what is the time interval? T. Change in momentum is written as delta P. Okay. So this is how you can write. This is vector. But in 9th standard, you can avoid writing vector sign. Mass is scalar. So everything else is vector. Force and acceleration is vector. Okay. So read the statement of Newton's second law. Is it clear to you? If you have book, this is the statement in the blue box. In volume also it is given. You should be able to understand. We are discussing unit C. Yeah, C only, just read the statement. So it states, according to Newton's second law of motion, the rate of change of momentum of the body is directly proportional to the force applied on it, and the change in momentum takes place in the direction in which force is applied. So this derivation is asked sometimes. State and derive Newton's second law of motion. That means you have to derive till F is equal to ma. First you have to write the statement and then you have to do the derivation till here. So first you'll write the statement, then do the steps. Okay? You need not write this because this is a separate topic. You need to know momentum to carry forward from here. Okay? This is the concept of momentum. What is momentum? Product of mass and velocity. That is momentum. Are you getting it? The second law. First law, you were excited. Second law is about force. So, how much force acts on the body? Yes, Krish? How much force acts on the body? How much force is acting on the body?
Product of mass and velocity.
Huh? That is momentum.
Force is equal to
Mass and acceleration, not velocity. Product of mass and acceleration produced in the body. Okay? Force acting on the body is equal to the product of mass and acceleration. Who is causing this acceleration? This force.
Force is causing
The acceleration. अगर force नहीं लगता तो ये क्या था? Zero. No acceleration. The body was at rest maybe, or it would have been moving with some velocity, right? Only when force is acting, the velocity is changing or acceleration or retardation taking place. So if the force is acting in the opposite direction, then a moving body will come to rest. That time A will become retardation. Understood? So force can either assist motion or it can resist motion, depending upon in what direction it is acting. Clear? So become more clear when we solve numericals. So there are many examples of Newton's second law of motion. While catching a ball, the cricketer withdraws his hands along with the ball. So what will happen? Look here. So when he withdraws the hands, what happens? This time increases. When the denominator increases, the impact goes down. Is that clear? देखो यहाँ से फिर से बताता हूँ मैं. So let's discuss the examples of Newton's second law. So what is the first one? Cricketer is hands backwards while catching a ball. देखो, since F is equal to MA, which is equal to M okay, now we are doing the reverse calculation. This is MV minus MU divided by. This is what we are getting. So this is the formula for force, right? Either if acceleration is given, you will use this formula. If initial and final velocities are given, you will use this formula along with time. Now see, like I said, if he grabs the ball right there, what is T? Very small. If T is very small, F becomes very large, right? देखो, अगर example ले लो, if mass is, let us say, 0.1 kg is how much? 100 gram. Let's say it was coming at you with what is the speed of ball? 100 kilometer per second? 100 meter per second. Okay, let's say it is traveling 100 meter per second. That's just hypothetical, right? Okay, so is it initial speed or final speed? When the ball is coming towards you?
Final speed.
Initial speed. Final speed is when you hold it. That becomes 0, right? Now, when you stop the ball, V becomes 0. Let us say you take 0.01 second to stop it. 0.01 second to stop it. What is 0.01 second? Very small. Just 1/100th of a second. Very small. Means this almost did not move. Okay? Then what is the force now? Calculate force. So it is M, which is 0.1. B becomes 0. This is 100. And this is now 0.01. Now how much is this? This is 10 by 0.01. 1000 Newton. This is 1000 Newton. The impact is 1000 Newton, right? But now let us say you pulled your hands back. When you pull your hands back, if T is equal to, let's say now, 0.1 second, right? Now what do you do? When the ball is coming towards you, you just pull it here and यहाँ पे रुका है, ठीक है? So now time becomes 0.1 second. So then it will become 100 Newton. 10 times less. You just did little pulling back of the hand, and now that will be 10 by 0.1, which is 100. Therefore, impact or force. Let's take it as 1 second. 1 second. 1 second कर लो तो तुम्हारा फोर्स और कम हो जाएगा. ठीक है? So when you increase the duration of change of momentum, right? So the rate of change is very small. The force or the impact is reduced by 100 times. Because now you have increased the time by 100 times. Okay? So there are many other examples. So in the high jump event, right? So if the athlete is made to fall on a hard surface, he will badly hurt himself. That's why what is kept? Cushion. So when he lands on the ground, when he lands on the cushion, the rate of change of momentum is reduced because now the cushion goes down and his momentum, if it was hard surface, momentum comes to zero suddenly. But on a cushion, it comes to zero after a while. So whenever you increase T, the impact is less. Okay? Whenever you increase T, impact is less. Understood? Like slapping, like I'm going to volunteers. Why not you? So if you receive a slap like this, and you don't move your face,
So it would learn.
The bones will receive the damage.
so it will be like it will hurt you really bad.
Calcium in your body.
Okay, very bad hurt it will cause. But if the slap is landing on your face and you
Dodge.
dodge or go in the same direction as the slap, then what happens?
Yes.
You increase impact is reduced. Yeah, he's experienced. That's impact. Okay, so what you're doing is only increasing the time. Okay, so the slab comes to rest, but then impact is very less.
So what if we do like this?
Head on, head on.
Plus the
Your hand, it depends on what is faster. Your piece is faster.
You can, not a good idea. Your teacher might ask you to demonstrate, then it is bad.
Then you have to resign.
Huh?
Teacher has to be done. See, you resign
Or the teacher will tell us that I want to try to.
Yeah, exactly. Why to give wrong ideas to teachers? Okay. So you have 3 examples given in the book. Athlete often lands on a sand or foam after taking a high jump. Okay. Third is when a glass vessel falls on a hard floor, they break, but they do not break when they fall on a carpet. Okay. Or sand. Same reason. If it is not a hard surface, the rate of change of momentum will be less because of increase in time. Okay. So any more questions on Newton's second law? We'll discuss units of. Did we discuss units of force? Okay, let me give you some more units of force. Okay. So is the examples of Newton's second law understood? All the three examples. Anybody has any concern? What was the second example we discussed? Newton's second law.
When an athlete falls on the sand or in soft
Hard surface or on sand, right? And the third one, glass vessel falling on a hard floor, hard surface or soft surface like sand, etc. Okay.
Catching a bullet.
Catching a bullet. Oh, Bruce Lee. Yeah? You're a Bruce Lee.
दूसरी भी नहीं कर पाएगा
बोलते तो हैं कर लिया था उसने फिल्मों में किया है फिल्मों में रियल लाइफ में पता नहीं ओके यूनिट्स ऑफ फोर्स
ask your World War II.
व्हाट यूनिट ऑफ फोर्स वी डिस्कस्ड
6.
व्हाट इज गोइंग ऑन हियर
So he threw a pen at me.
so what is the SI unit of force 1 Newton okay so this is SI unit you also have CGS unit this is SI unit in CGS system one time 1 gram per centimeter per so in CGS system the unit of force is called dyne okay and it is defined as gram centimeter per second square so what is the relation between 1 Newton and dyne therefore 1 Newton is equal to 1 kg how much is a kg 10 raised to 3 gram how much is a meter 100 centimeter
Sir,
yes
do you have a student named Mohammad Azam in Kharghar branch?
Muhammad Ayam yes
Yes.
not in Kharghar Kopergaon
Yeah, sorry, Kopergaon.
yes I do have yeah
You don't feel it, sir.
why
He's in our
Yes.
class.
Acha. how is he
हमारी class में हमारे class में
मतलब क्या why did you take his name particularly because
no, just asking general knowledge.
मेरे ठीक करता है एग्जाम में तो अच्छा स्कोर कर रहा है how is he
अरे वो
doing
तो-
in school
Yeah,
good काफी studious बंदा है
physics में physics definitely.
No, it's just in physics, like in the physics lecture.
हाँ स्पेशली फिजिक्स में ही
बस।
बहुत ज्यादा सोचता है
बस और कुछ नहीं.
और कुछ नहीं मतलब बचा
कुछ
गया
नहीं, और-
फिजिक्स इज स्टडी ऑफ यूनिवर्स व्हाट इज यूनिवर्स
Start the bullet faster than the bullet.
ओके नहीं मेरी क्लास में तो ठीक कर रहा है मींस बाकियों से पूछना पड़ेगा हाँ why you are planning to shift to Kopergaon
No, I'm just asking.
so I visit all branches all five okay so is this clear what is dyne dyne is nothing but gram centimeter per second square ये जो kg meter per second square है वो gram centimeter per second square हो गया and the relation between Newton and dyne is 1 Newton is equal to 10 raised to 5 dyne
So KGF क्यों होता है? KGF.
kgf is gravitational unit of force वो भी होता है ठीक है so that we will see later do we have kgf Okay, let me tell you, since you have asked, there is a separate topic, mass and weight. When we discuss weight, that time we'll discuss. That is the last topic. Okay? When we discuss mass and weight, that time I will give you that unit, kgf. Kilogram force it is called. Because before that we have to understand what is gravity. We are yet to understand gravity.
But I know Newton's law. Every action has an
Equal and opposite.
support.
You know the statement, but you don't know the law yet.
Like I guess.
Okay, tell
When
me.
you shoot,
Like-
recoil.
I not like that. If I slap him, he will go that side and my
He will slap you back.
Yeah,
Which-
sir. Every
Which you
action.
will not be able to stand.
Every action.
If you shoot someone, who's going to shoot you back?
No.
Arey,
you
what is
shoot
wrong?
on the arm.
It isn't
Okay,
necessary. You
so
do the same.
Newton's third law is the easiest law to remember, but difficult to understand. So pay attention. What is Newton's third law?
Every action has an equal and opposite reaction.
Right. Well, I know this.
You shoot someone,
So what is the statement? It states that we did not write the statement for the second law. That's a lengthy one. You write it from the book. Okay, I have just read it for you. Like, what does it say? How will you state? Force acting on the body is directly proportional to its rate of change of momentum. This is Newton's second law. What is second law? Force acting on a body. Newton's second law states that force acting on a body is directly proportional to its rate of change of momentum. Okay? And the change, it acts in the direction of change in momentum.
So,
Where the force acts in the direction of change in momentum. Like for example, when the ball is coming, now you tell me, when the ball is coming and I am stopping here. So when the ball came and stopped here, where did the force act? What is the direction of force? Did I stop it opposite to motion? Where is the motion? And where did I stop? So direction of force is here. So where is the change in momentum? Negative. Correct? That's what we got here. What is it? This should have been negative. Nobody told me this is negative. Isn't it negative? Final velocity 0. Make that correction. So the change in momentum is the direction of force. Okay? So it is opposite to the direction of force. Right? In this case. Now the statement of Newton's third law, it states that every action has equal and opposite reaction. It states that every action has equal and opposite reaction. Now tell me what is action and what is reaction here? Huh? Every action. What is action? Action and reaction are forces. Okay? Where action and reaction are forces. What kind of forces? Acting on different bodies. Yes. Acting on different bodies. Will action and reaction cancel each other? Why?
Because in action, there is no
Yes.
but in reaction, there is no.
Yes.
Will action and reaction cancel each other?
If we take
If every action has equal and opposite reaction, will they cancel each other?
आधी बची.
किधर है वो?
They do not cancel each other. Action and reaction. Everybody pay attention here. Action and reaction do not cancel each other. Instead, both leave their impact on respective bodies. So, for example, suppose you have two objects like this. They are both traveling in this direction. This by u1 and this by u2. And u1 is greater than u2. So what should happen?
Collision.
Collision will take place.
Crash.
So it will, after some time, it will hit it. Right? So collision takes place. And collision, the time for collision is t. Collision will take place for a short duration. During this time, the first body, let's call this body as
A.
A and this body as B. So both will apply force on each other. So this force will be FBA and this force will be FAB. Understood? At the point of collision, both bodies will apply forces on each other. So what is FBA? Force on body B by body A. And FAB is force on body A by body B. चल क्या रहा है ये सब? तुमको बैठना ठीक नहीं लग रहा है क्या?
पर वॉशरूम में तो ये दोनों से मेरा बैग से सामान निकाल दो। ये दोनों।
चल खड़े हो जा तू.
और ये तीनों ने।
स्टैंड अप. खड़े रह तू. जिसने भी लिया हो. किसने लिया है? क्या नाम है इसका? ध्रुव. चल खड़े हो जा तू. खड़े हो जाओ. जो गड़बड़ कर रहा है. तूने क्या किया?
बैग में रख लिया।
इसलिए आया तो यहाँ पे. खड़े रहो तुम दोनों. तेरे को तो आज छोड़ रहा हूँ मैं. अगली बार तेरी क्लास लगेगी. ओके. Will they cancel each other? FAB and FBA. You stay silent or next time out of the class. If I hear your voice one more time. Anyway, it's time to go out. Okay, so what happens now? This will travel with some other velocity. This will travel with something else. So FBA, what is the direction on the second body? It is in the same direction of motion. So this body will accelerate. And this body will retard, because for this body the force is in the opposite direction of motion. Understood? So after collision, this will slow down and this will go fast. Clear? So these forces are not cancelling each other. They will both leave their impact on respective bodies. Clear? Understood? The forces are not cancelling. So what is FBA? Action. You can call FBA as action. FBA is force on body B. By body A. What is FAB? Force on body A by body B. So this you can call FBA, and as per Newton's second law, FAB is equal to minus FA. This is the meaning of Newton's second law. Chalo बैठो चुपचाप. This is the meaning of Newton's second law. So FAB is action, FBA is reaction. They are acting in opposite direction. That's why minus. Okay. So there is reaction.
So,
Yes.
where to do?
Yeah.
Like,
So FAB is reaction and FAB is ठीक है. So action reaction could be anything. Okay. ये अगर एक्शन लिया तो ये रिएक्शन हो जाएगा और ये एक्शन लिया तो ये रिएक्शन हो जाएगा. फिक्स नहीं है. कोई भी एक फोर्स एक्शन ले सकते हो तो दूसरा क्या हो जाएगा? रिएक्शन. एक्शन एंड रिएक्शन इज इंटरचेंजेबल बिकॉज दोनों का वैल्यू सेम है. बोथ फोर्सेस हैव इक्वल. Negative sign shows that action and reaction in opposite direction. So action and reaction act in opposite direction. Directions. Okay. So let's discuss some examples of Newton's third law. So take this example of duster kept on the table. So can you identify what are the forces of action and reaction? The duster kept on the table. How many forces are acting on it?
Gravity.
atmospheric pressure and
We will not discuss pressure. Only contact forces.
Normal reaction.
Normal reaction upward. So who is causing normal reaction? The table surface. Normal reaction is caused by the table surface. And what force the duster is applying on the table surface? Its weight. So its weight is because of gravity. Okay. So action is weight of the duster on the table. Reaction is the normal reaction. Likewise, if we take the example of gun, when the bullet is shot by the gun, then what is experienced? The gun experiences recoil. The moment bullet is coming out, the gun goes back. Okay? There is a sudden jerk. That is called recoil of the gun. So force on the bullet by the gun is action. Force by the bullet on the gun is reaction. Okay? So we'll do more examples in the next class.
Slightly nail. Yeah.
I got shocked purple डाल दिया.
Shock.
Shocked purple डाल दिया. You got
Something is not being put in the box. I'm not coming to this. Like I'm not going to.
Prismatic. Peristhematic.
Charismatic means.
Meristematic tissue.
Sides.
किसका मुख है? I don't know.
Who does?
My brother.
It's
Not
Yeah. And